Monitoring is really important for keeping our computer systems working constantly. When we talk about monitoring problems, we immediately think about machines going down. But sometimes it's not the hardware, it's the services and apps that are crashed. Or they may actually work, they're just slowed down enough to crater productivity. In these cases, you need application performance monitoring, or APM, to directly monitor the app itself. APM helps us track down the root causes of problems, helps administrators fix them, and prevents them from happening again. So how do admins find the root causes? The best way is graphs based on time, where you see whether the behavior is what you expected or not, and compare multiple measures at the same point in time. And just like graphing CPU usage over time, you can also graph how long the steps of your services and applications take, and see if they matched what you expected. Graphs usually show us two types of problems: anomalies, which often look like events with spikes, and degradation, which usually shows slowly increasing resource usage over time. When services and apps degrade slowly, it's not really noticeable at first. Things take just a bit longer than usual, and you think you'll be back to normal next week. But over weeks and months, those small bits add up, and at some point, everyone will notice. But what's actually happened is that for those months, everyone has been less and less productive without noticing it. So why not use a classic check like CPU load or ping? The problem is these aren't necessarily correlated with app performance. Checks that tell you if something is up or down can't let you know a service is degrading over time. Instead, we need our check to return a range of values like time, so we can compare the relative strengths of two different measures. Here, we have 3 test cases on our very own Kibana installation that measure how fast Kibana reacts when a user is trying to use it. While you can look at a single report to see a snapshot in time, by itself it's not a trend that would show degradation. The report tells us how long each step took and can show us actual screenshots taken when the test case was running, adding the areas that Alyvix was looking at. These aren't complicated test cases. The first one has 8 steps and the other 2 have 4 steps each. They're just looking at whether very basic functionality is there and how long it would take a user to go through that sequence. When everything goes well, we can use this data to check if there's degradation. When a step is so slow that it takes longer than the timeout we set for it, we can instead try to resolve that particular problem. To gather the data and view it graphically over time, we can use monitoring systems like NetEye and tools like Alyvix, Elastic, and Kibana. Each of these tools works in a unique way. Alyvix schedules and runs the synthetic monitoring checks that generate application performance data. It then delivers it to NetEye, which shows it as stacked graphs indicating runtimes of the steps and the entire test case. Elastic and Kibana do something else, generating hierarchical trace graphs. We often use these tools separately when trying to find the root cause of a problem. But complex problems like service degradation can be more quickly solved by using them together. And that's where NetEye comes in, providing a single platform where all these tools and their data and graphs can be coordinated in one place. So in practice, how does this work? Often when you suspect a problem, the first thing you do is turn to the highly useful ITOA graphs on the NetEye platform. Here, for example, we can see an obvious slowdown. What is it? Is it a significant problem? Our ITOA tools let you drill down to find out exactly what steps in your Alyvix test case were affected and when the problem occurred. The next step is to turn to the report section to verify the nature of the problem and gather more information. By finding the test case report with the matching day and time, we can see exactly what a user would have seen when the problem occurred. But to find the root cause, we need to see what else is going on inside that machine besides our application. Many times when an application just stops, it's the application's fault. But when there's a slowdown, it's often due to some other problem on the same machine. Kibana lets us look at that other information. Through Elastic, it gathers trace-based information from the system and other applications and organizes it so all the data can be viewed across the same time range. Within Kibana, we can look at all those traces around the same time frame as the original problem we noticed in ITOA and analyzed in the reports. Here, each row corresponds to one trace. Many of the traces will show no significant problems, the black squares in the rows. Other rows may show anomalies at multiple times, not just when our problem occurs. And some rows will show anomalies only when our problem occurred. Those are the possible causes we want to look at more closely. One of the rows that match these criteria is the second row, which we can tell from the row label is a heavy machine learning job that ran on our system at the same time we saw our significant slowdown. Our system administrators can then take these very specific clues and make system adjustments to alleviate the problem in the future. So unified monitoring with Alyvix, NetEye, Elastic, and Kibana supports your efforts to find degradation in your apps and services by seeing slowdowns in monitoring data that Alyvix records from your applications. You then compare them with the app's own interface when those slowdowns occurred, and finally use Kibana's machine learning tools to correlate them with other data and events taking place on that machine. Boost your workforce's productivity with Alyvix, NetEye, and Elastic.